All right. Welcome, everybody. Another edition of the Fluence Technical Community Call. Get a full deck today. We get Anna giving an overview of upcoming events and hackathons. We got Folex with stuff, including TrustGraph and Registry documentation, our new Aqua metrics, log collection, and VSCode advancements. And we have community members, I think. Are you here? We're looking for Sorgan and the DOSA team. Okay, so we got that. All right, so and then with Ivan, who's gonna give a deep dive with the AquaVm performance analyzer, and I've had a preview of it. So if you're in Aqua and AquaVm, definitely stick around. All right, let's start with Anna.
Right. So there are some of the upcoming events that we are participating and also hackathons. So first of all, just to remind everyone, we have community calls. It's every month now, and the next one is September 1st, then October 6th, November 3rd, etc., etc. It's every first Thursday of each month. We get together here in Discord. We're not using Zoom. And recording is going to be in our YouTube. Then the first Fluence meetup in Nigeria, built by one of our community members, active community members, Purity. So it's happening actually on Friday. The information in our Discord. Then we probably is gonna one of our team members is probably planning to participate in the Meta Cartel conference in Denver. So if you want to get to know more about DAOs, feel free to join that. Then there is Berlin Week, the massive blockchain week, September 12 to 18. AdaptCon, the conference for Ethereum developers and developers who want to build with decentralized stack. Our team is planning to be there, so very welcome. Let's meet and chat. And the well-known ETH Berlin, September 16 to 18th. So full week of events. ETH Berlin is going to be only offline, I think, only in person. So you can apply now. Token 2049, that's the big crypto conference in Singapore, running through the September 28th to 29th. We are having M4 stand there, so you can see it right here. So there are a lot of companies are planning to be there, and us as well. And they're also, okay, I'll tell a bit later that Phil Community is planning to have conference as well. And that one is All Things Open in Raleigh, US, October 3rd, sorry, I keep cutting out. I think that I don't know what to do actually with that. I think that's because I
hear you well, so it's fine.
Okay, maybe I should speak louder or something. I think because I'm recording the same time, it's not running. But anyway, that's the conference for all open source, about the tools, about the like technologies for the developers. Then Lisbon Week, again, ETH Lisbon, hackathon offline, in person, the week of events around it, Filecoin event, the big Filecoin conference, you can see here some of the dates, Compute on Data, community meetup, and Solana Breakpoint conference, and a lot of other conferences. Just watch Twitter and there are going to be all the updates, and I'll post this this PDF in our Discord and in our community calls wiki. Then some of the hackathons that are running right now. You can still take part in Web3 Infinity Hackathon run by local Singapore community. The deadline, I think it's August 17th or something, and hackathon is running until August 23rd. 3rd. It's via DevPost. Check out, you can build with Fluence, check out the rules there and submit your project. We have we have a workshop published in YouTube already. And they're going to be in-person conference, as I mentioned, just before Token 2049 in Singapore, the Big Filecoin Singapore Summit. Also very, very welcome. I think it's going to be also probably online live streamed. And Polygon Buidl It Hackathon. The total bounty pool is over 500,000 and deadline, the extended deadline is September 5. So very welcome. We also have published our workshop and this is the website. You can still take part. These are more of the upcoming hackathons. We haven't decided if we are participating yet there. Sorry? Yeah, okay. That's it from my side. Thank you so much.
All right, very cool. Lots going on. You want to hack? This is plenty of opportunity. Okay, so next we get the DOSA team from Hackathon. Why don't you tell us a little bit about your project, and congratulations, by the way, you did very well. And yeah, just let us know what you did, how you did it, and what you gonna do.
Thank you very much for that. Actually, just to be honest, it took like 3 weeks to understand Fluence and build it. Right? I mean, for today, we're going to share, let me share the video. Sorry, did I share it? Am I sharing the right screen?
Again. And the second one is attaching a skin of a rocket ship into the existing one at a place we call DOSA workshop. To play the game, first we must move the rocket ship NFT. Use the Polygon network. Now, when the rocket is ready, we can then place.
Вот не пускай. В ванной иди пускай.
We also support multiplayer. Now, the second part, we call it the DOSA workshop. This is the place where users can attach a rocket ship onto their current NFT. We call it a consumable NFT. We reconnect to the DOSA workshop. Now we can see the skin has changed. We can go back to the play. We can go back to the game and play again. Thank you.
All right. That's the gist of what we are building for the hackathon. But I assume that it doesn't explain much about what's happening around it.
Exactly. So why don't you tell us?
All right. Let me share my screen here. All right. So for this part, we actually helped you to prepare for some slide information how we actually work with Fluence in terms of getting what you saw inside the video just now. All right. So I'm sorry to say that actually this project has been built by me and my friend. He's actually here also, Joe Elliott and Saifi as well. So 3 of us is the one actually working on the project. So what we actually try to build is what we call decentralized infrastructure with a mutable NFT. So what you can see just now is that what you see just now is actually how we combine 2 NFT metadata to 1 metadata, right? So basically our background is that we actually came from what we call a game industry, right? So we actually build blockchain games. So they actually have a lot of limitation in building what we call a crypto native game. So most of the time, the implementation is actually more towards you need to combine a lot of what we call a Web 2 and a Web 3 technology together to build a single game, right? So the very high, the most important part is actually the in-game, we need a lot of what we call high throughput, like in terms of what we need to streaming the game, and we need to stream about the information, and also in terms of changing a blockchain itself to become a database, right? So this is actually the infrastructure that we built at the back. Actually, one of it that you can actually check out in our, I will share it afterward, that this is actually the codes that we publish for the hackathons. So what we built is we actually work with two blockchain for the project. One is a Polygon blockchain, and another one is a BigchainDB, whereby it's actually a blockchain database. BigchainDB is mostly used a Mongo and Tendermint as the base, and Polygon as it is. So how the transaction be happening is actually that I will explain about the detail part on the word down below. So as you can see that we're actually using also the graph in terms of indexing the data of the smart contract, and we are using the service on what we call a cron job. Right? We are running on the background service of every 100 seconds to actually read. One thing that we actually missed out on is we actually plan to do a consensus. It means that we are reading it for a different resources. We're actually planning to use a Moralis and the graph, but because of the limit of time, we just stick with the graph, and we didn't manage to do the consensus part of the Fluence, right? So once they read the information from the graph, then only the certain information actually going for to remin to mint the NFT to the user wallet with a randomized stats. And it also be used also for a couple of things. So they actually, in general, we have a couple of services that you can see here that we run in. We have but to sum it up is that they have two main things, basically the DOSA main service and DOSA game service. DOSA main service is the one that interacting a lot on these two blockchain, whereby the DOSA game service is the one that interacting to the game, right? But we're having a problem when we try to implement the service directly into a Phaser 3 game engine, right? I'm not sure something that is, when we try to compile it, it cannot read the Fluence.js. Right, so to solve it out, we actually build a socket IO, right? So it means that the socket IO become the communication channel between the game services to the game itself. So, and on top of that, the game service also is actually inclusive with, we actually tried on this hackathon, but we didn't manage to complete. What we do is we're building an anti-cheat system, whereby we are sending the information directly from the game in a certain interval for every hit. Right, for every count, and the information also been. Another thing is that the data are being stored also, but this is a bit incomplete. That we actually try to pull everything together to the IPFS for any of the services. We broadcast out to the IPFS. Okay. So this is the general idea of it. So this is how the information looks. Basically, the Oracle is the part that the service. Every time you do the mint, you do the relayer, then we actually mint the NFT to the user. So then after that, the information are being stored inside the BigchainDB. Right, so for the service itself, we actually store the key for the BigchainDB information. So it means that the service will be what we call the point of contact or the trust to actually update the BigchainDB of a certain metadata. Right? So this is so the one that you see actually for what we build. One thing that we try to build is what we call a consumable NFT. So most of it, like the biggest problem in the game industry is like when you try to combine multiple NFT to a single NFT. So most of the time, like if you have two NFT, you need to burn two NFT and build and create another NFT, whereby it's actually it's not efficient in terms of the gas and also for the process. It's not seamless. So what we build, So what we do is actually the service, one of the service whereby the DOSA means service will be the one that actually responsible to do the check. So what we try to focus to do is actually because we are actually interacting for two blockchain. So to produce a seamless and decentralized oracle to deciding in terms of merging between the base and also for the slot NFT, right? So what we call the slot, the skin that you saw in the video just now is what we call the slot. So it means that anyone can create a skin right now. So the idea is that anyone can create a skin, and the skin then can send a request through a smart contract, a special smart contract, and it can merge directly to what we call the base NFT, whereby it's the base rocket that you saw just now, and it's updating the metadata directly from that, right? So yeah, so that's basically, I guess. So on this part, it means that every time we do the merge, all that, we are updating the base metadata in terms of adding the what we call the NFT, information, the slottable NFT information back to the base NFT, right? So from there, then so it means that we generate what we call we plan to do more what we call a creator economy on this space using this what we call a consumable NFT. Okay.
Very cool, very cool. Anybody have any questions? It was a great, it was fun to judge. Nobody? All right, I have a couple of questions for you. First of all, it took you 3 weeks to figure out what Fluence was doing. What tripped you up, and what made you persevere to actually try and understand it?
I mean, both three of us, we actually came from what we call a Web 2 project developer. So it means that our background has always been building in microservices, API, REST API, all this, right? So one thing that struck us is actually the infrastructure is not. We have been through like a couple of hackathons, right? The services that have been provided, the things are not really to the things that we are looking at, because most of it is not scalable. Whereby actually at the first, we all didn't know about the Fluence, right? But when we attend your session, actually, I mean when we attend the session, also we actually like still blank in much of the things. But one thing that triggers this is actually the idea that we can actually build a more decentralized Oracle system, right? Because if you want to build up a communication between these two, what we call these two blockchain together, right? So most of the implementation nowadays is using what we call a centralized solution, deploying in AWS and so on, right, in the cloud. So it triggers that we want this to be like as our what we call a learning ground, a playground. We don't really mind that we lost also at that point. Like we just want because I'll be honest with you, we are attracted with the Fluence technology by that point, right? So we said, okay, we need to try. So I think I did ask a lot of questions inside the group and the Telegram group at that time. I know some of it is actually quite a stupid question at that point, but because that we try to understand what's going on this part, like it is. And that's what makes us like, we need to stick with it. Doesn't matter. Because at that time, we have 1 week before the submission, we said we don't mind, we don't really care at that point. Like, we just need to complete it. We just need to have this, because this is, to be honest, it's not trying to put you out. It's just that, like, what we feel this is basically the solution that can solve a lot of problems. So we need this. Doesn't matter for the hackathon at that point. We just need it for our projects and ongoing things that we are doing. So we just keep through it. But luckily we managed to complete it. But even though we cannot complete all of it, but we managed to complete at least enough for the presentation, I guess.
Very cool, very cool. Well, again, congratulations, and definitely stay in touch. And we got a few rollouts, and I think Folik's going to talk a little bit about TrustGraph and registry documentation, which I believe will be helpful for your future endeavors. Anyway, congratulations again. Well done.
Thank you very much. Thank you very much.
Well, Alex, you good to go?
Yep, sure. So, let me share this. Do you see the infinity? So what should I start with? Okay, so I want to show you that we implemented log collection for our network. So now we can like better debug this stuff when people come to us with problems, and soon, sooner or later, I hope sooner, we will have a thing so anyone who runs their own Fluence node will be able to send their logs to this system and be able to just use our infrastructure for debugging and for observability into their own networks if they like want it. Or as well, we provide like all this is open source, so all this infrastructure as code is open source, so you can just run your own log collection for Fluence pretty easily. And we will have a documentation over it. But right now it gives us the actual like look into the system, what we're like, what's happening. For example, I can see that here's a particle, it came at this time, and it went through all these nodes, and it did something in that time. And I can like debug further, and yeah, so that's log collection. That's pretty awesome. Yeah, and we're constantly working on metrics that I usually show a lot, so but not much changes, and soon will change a lot. Okay, so that's log collection. As Bernard said, yeah, we'll talk a little bit about registry and TrustGraph documentation. We have a huge effort in writing and rewriting, editing and re-editing the README and documentation for registry. That's our service for service discovery. That's our basically tool for service discovery. It has now nice pictures that hopefully explain what happens. If you find something here confusing, or you find some mistakes or anything at all, you can always come to us to Telegram, Discord, or just create an issue here, and we will discuss it and fix. But yeah, I think those pictures, they give a good overview of what registry is. It's like a thing that you can that allows you to store routing information for services. So if you like deploy a bunch of services, like 10 of them or something, and you want the services to be discoverable by other people, you just share with them a single identification string, and they can find their services in network registry. Yeah, so that's basically a decentralized content discovery, like service discovery, computation discovery thing. Yeah, so that's pretty awesome. What guys did there. Also, a huge effort was into the TrustGraph documentation. It has similar structure. This is our distributed public key infrastructure thing that allows you to assign different weights to different services. Soon we will use it for resource management. So like more trusted services will get more resources, resource allocation, stuff like that. So it all will be programmable and flexible. And yeah, it's already there. You can already start to learn about it. And soon we will integrate it into registry completely. And it will be possible to discover services judged by their weights in TrustGraph. So yeah. Okay, another thing that we have, is, where is it? Okay. Is we have implemented, let me make it a little bit bigger, we have implemented metrics that are available from within the Aqua. So it's a service metrics. So if you, for example, have some service, for example, here I have a built-in service called registry that we just saw documentation for, and it like has some functions, and these functions you might want to know how often they called, how many calls were there, which calls like failed, which calls took what time on average, or here we show like average time, call time, and last 5 calls. And also we show the change in memory consumption by the service. So you here it's 0 because the function merge is stateless and it doesn't consume any memory, but if it was, there would be different numbers, and you can track like allocation of memory in your service. That's very useful when you deploying your own services and you want to know how they perform, like which functions are most used. Like if you think about it as an API, that's basically metrics for your API, for its call time, for performance, for memory usage, and for popularity, should I say, yeah, for how many requests are there. So yeah, and I hope at some point we will draft some dashboard for this metrics, so it will be possible to like explore the network and see which services perform how, and see charts on that stuff. So yeah, that would be awesome, but that will take time. What else yeah, and also we've been working hard on the VSCode integration. So now with Aqua. So we have a programming language for distributed algorithms, and we have a VSCode plugin for it, and it supports different things now. For example, it supports going to definition. So you can go control-click on a function name, and it will go to the service where we'll show you like the definition of that function. Same works for like services themselves, and same works for data structures. So if you like point and click on a data structure, you will see what fields it has and where is it defined. Also, a very important thing is that if you have some imports, you can now click on them and actually see their API. Before that was pretty hard. You had to go to GitHub and read code there, but now you can just control-click on imports, and you will see like what kind of built-in functions Fluence protocols provide. For example, you can concatenate arrays, you can like connect to create services and stuff like that, and it's all documented all here. So yeah, that's a pretty big change in quality of life for developers. And I guess that's it. Yeah.
Okay, well, in that case, Iman's gonna give us an overview of AquaVm Performance Analyzer. Take it away.
One of concerns for our team in previous month was performance, and performance of AquaVm as one of key components. In a perfect world, one would just profile the WASM binary, but currently profiling tools for WASM are very limited. And instead we introduced tracing crate, common Rust tracing crate from the Tokyo project that allowed us to measure execution time of different parts of the AquaVm. Tracing, of course, is not good for estimating performance as a proper profiling. However, for coarse-grained parts, it works very well. And to run the AquaVm locally, one needs some tool. It wasn't possible to run it locally before. So AirTrace utility was introduced. It has two subcommands: run to run air script in AquaVm, and stats to process some statistic gathered. First of all, we need to build AquaVm. We build it with Marine, just standard operation. However, make sure that you build it in release mode, because measuring performance of debug mode is close to useless. Okay, let's do it. The AirTrace utility, it needs to know the path to this binary. However, if you run the utility from the project root, it will use default value that is going to just work. The run subcommand needs interpreter. You see the default path. Some flags that affect marine WASM runtime, and tracing params. It's just standard string for tracing crate. It can be info, debug, trace, and it can be warned, for example, to completely disable it. You will see why you might need it. So, and it has two subcommands, plain and anomaly. With plain, you define input data for the AquaVm execution, data, different IDs. You define it explicitly, loading from different files. Peer ID, for example, initial script, timestamp, and so on. You define it explicitly, and with anomaly, you define just single anomaly file. Anomaly files are collected by our Fluence node, or by any Fluence node, and just a single file stored for particle executed for more than half seconds. So for plain, the only required parameter is data. Other parameters have same defaults. And I have just some large data. Let's see how it works. Oh, I'm sorry. I need to provide a script. One can provide script as a file, or by default, it just reads from standard input. I provide simplest R script possible. Let's run. So you see the execution trace of default granularity, and for example, loading of this data took 5 milliseconds. Other stages are not significant here because we had a very simple script, but as an example, it would work. And it printed the outcome of the execution. So one can use also JSON trace. It's the same trace, but is output in JSON format for future analysis with air trace or even with JQ. Let's start. Pay attention that you need to forward standard error. So now comes to play the air trace statistics. The air trace, the air stats subcommand has two main features. It just pretty prints the same trace that is stored in JSON format, and it provides cumulative statistics on execution of different spans. If you provide no arguments, like here, it will just do both. If you provide any or all, it will do what you requested. Another important execution option is native. It runs AquaVm compiled in native mode. And it is useful for two things. First, you can run it with real profiling. While data will be different, it may provide some hints. And another, you can debug. You can run AquaVm with debugger and see what is happening inside and what is not happening. And that's basically all. And you can repeat because AquaVm usually executes very quickly. To gather proper profile and statistics, you may repeat it many times. For example, even 100 repetition takes less than 1 second. Okay, 6 seconds enough to gather some statistics, some profiling info. Thank you.
Thank you. Anybody have any questions? Come on.
You say the statistics was cumulative. You mean like that it's the sum of every number that was in the lab?
At more detailed tracing levels, there are some operations that are executed repeatedly. And this report just sums same spans.
Makes sense.
Anybody else? All right, and I have some questions. First, how does a developer who wants to get more information actually start using AquaVm Trace? What do they have to do? How do they set it up? How do they prepare the data that needs to be processed like you had in that file? If you could maybe speak a little bit to that.
First, data is a key conception of the AquaVm, and one just need to understand it to get it somewhere, or to be able to write manually that I did. It's JSON, big JSON or small JSON file of particular format. And as of installation, the tool is stored in tools CLI trace folder, and it's just ordinary Rust binary. So common installation, common Rust installation procedure will do. Or one can even run it with cargo run within AquaVm project.
Well, thanks everybody for tuning in. Once more, congratulations for the DOSA team. Stay in touch. Did a great job. Looking forward to see what you can do with it and push the envelope. And we'll see you in 4 weeks. Goodbye.